We are going to start now the next lecture, lecture 3 of chapter 1, class 11th mathematics sets. In this lecture, we will talk about operations on the sets. So the first operation we have, it is union of sets. So union of set means if we are given two sets A and B, then union of sets, it is denoted by A union B, and it is another set. This A union B, this is another set, and it contains all the elements of A and all the elements of B. So we are saying A union B is the set of all those elements which are either in A or in B or in both A and B. So this thing is mentioned over here, that A union B is equal to all those X. This X means it is a collection such that either X belongs to A or X belongs to B. So in Venn diagrams, it is shown like this. Suppose we have, this is U is the universal set, and these are the two sets A and B we are talking about. Then the union of set means we are talking about all the elements of A and all the elements of the set B. All these elements, they together form the union of these two sets A and B. Over here we are saying neither A is a subset of B nor B is a subset of A. So the things will be more clear to you with our next example. So two sets they are given to us. One is this set A is equal to 3, 4, 5, 6, and second is the set B is equal to 4, 6, 8, 10. We have to write A union B. So first thing we have A union B, that is equal to a set. It is a set and it consists of all the elements of A and all the elements of B. So we are first listing the elements of A. It is 3, 4, 5, 6. Then we are listing all the elements of B. 4 is already written over here. Then we have 6 is already written over here. So repetition of the elements is not allowed in the sets. So the next element we will have over here, it is 8, and next element we will have over here, it is 10. So this is the set A union B for these two sets A and B. Next is, let A is equal to, this set is given X. X is a prime number less than 10, and B is another set, it is X, such that X is a factor of 12. So what are the elements of these two sets? The first set, it is prime numbers less than 10. They are 2, 3, 5 and 7, and X is a factor of 12. So what are the factors of 12? It is 1, 2, 3, 4, 6 and 12. You have to write the value of A union B. So that is a set. It is a set, so we will put them in this bracket. So the number we will have, it is 1, 2, 3. These three numbers, these are covered. Then it is 4, 5, 6, 7 and 12. So this is the union of these two sets. Next is, the set A is given X is a positive integer, and set B is given X is a negative integer. X is a positive integer means we are talking about the numbers 1, 2, 3, so on. X is a negative. The set B we have, it is negative integer, so it is -1, -2, -3 and so on. 0 is neither a negative integer nor a positive integer. So union of these two sets will be A union B, that is equal to, we are saying it is -1, -2, -3 and so on, 1, 2, 3 and so on. 0 is not included over here. We are not saying that this is not equal to the set of integers because 0 is not here. So we are saying this is the set of the union of these two sets A and B. Now if in place of this, suppose the sets A and B, they are, A is the set of X such that X is a non-negative integer, and B is the set, we are saying it is x such that x is a non-positive integer. In this case, we are saying the set x is, it is non-negative integers. It means 0, 1, 2, 3 and so on. The set b will be 0, -1, -2, -3 and so on. These are non-positive integers. And the union of these two sets, A union B will be the set of integers, because now 0 is included over here. So all the elements of set, they are covered over here. The next operation we have, it is the intersection of two sets. So we are saying if two sets A and B are given to us, then intersection of two sets, it is denoted by this symbol. This is the symbol for intersection. Is the set of all elements which are common to both A and B. So using the Venn diagram, this situation can be shown as below. U is the universal set. It is shown with this rectangular box. We are having two sets. This one circle A, this is representing set A and this is representing set B. So this common region over here between the A and B, that is the intersection of these two sets, A intersection B. So we are saying the definition we have is that A intersection B, that is equal to the set. It contains all the elements such that X is an element of A and X is the element of B. When we were talking about the union, this word and this was replaced with or. That either it is element of A or it is element of B or it is element of both, it is part of union. When we are talking about intersection, we are saying it should be both in A and B. So this is the situation shown over here. So what we get from this is, we are saying that if X belongs to A intersection B, we are talking about if an element X is over here, then this thing implies that X belongs to A and X belongs to B. Second thing that is shown over here, this second condition we are talking about, what it means is, if suppose we are considering any element which is outside this intersection, we are saying that element, suppose it is over here, we are saying X does not belong to A intersection B. So what this thing means, that X does not belong to A or X does not belong to B. In this case we are saying X does not belong to B. This statement, it is true, that X does not belong to B but it belongs to A. In this case we are saying X is in A but X does not belong to B. That is why we are saying that X does not belong to A intersection B. So this thing is will be more clear to you with this example. We are saying the set A is given to you. The elements of this set, they are 1, 3, 5, 7 and 9. And elements of the set B, they are 2, 3, 5, 7, 11 and 13. So what are the common elements over here? We are talking about the A intersection B. Common elements, 1 is not present in both of these, 2 is not present in both of these. This element 3 is present in both these. Then this element 5, it is present in both these. Then we have this element 7, this is present in both of these. So A intersection B we have, it is equal to the set 3, 5 and 7. This is the set A intersection B that we have. Next question we have, the set A is given. A is X, X is a natural number and X is a factor of 12. So the factors of 12, they are 1, 2, 3, 4, 6 and 12. Next we are talking about the set B. It is X is a natural number and X is a factor of 18. So the factors of 18, they are 1, 2, 3, 6, 9 and 18. We have to calculate the value of A intersection B. So the answer we will have, it is 1, 2, 3, then 4 is over here but it is not present in B, so we are not writing 4. Next we have, it is 6. 6 is present in both these. After this, 12 is not present, 9 is not present and 18 is not present. So we are saying the intersection of these two, it is 1, 2, 3 and 6. So these are basically the common factors. These are the common factors of these two sets. These two numbers 12 and 18, this set represents the common factors that we have. Next is, now the next question we have is that if A is equal to, this set is given that it is x such that x is equal to 3n and n belongs to z. So we are saying the elements of A, they are of the form, it is the value of n that we can have, it is n is equal to 0, plus minus 1, plus minus 2, so on. So when we substitute these values, we will get that A is equal to, it is 0, then it is plus minus 3n, it is not 3n, it is plus minus 3, it is plus minus 6, plus minus 9, plus minus 12, plus minus 15 and so on. And when we are talking about this set B, we are saying the elements of B that we will have, it is 0, plus minus 4, plus minus 8, plus minus 12 and so on. Now we have to find A intersection B. So the common elements we can see from this, it is 0 is common in both these. Then it is the next element that we will have, it is plus minus 12, that is common in both these. So the answer we are going to write, it is A intersection B, that is equal to 0, then it is plus minus 12. The next factor that we will add, that will be plus minus 24 and so on. And this set we can write, this is equal to x such that x is equal to 12n, n belongs to z. We can also look at this answer in this form, that we are saying, when we are saying x is equal to 3n, it means we are talking about all the multiples of 3. When we are talking about x is equal to 4n, we are talking about all the multiples of 4. So intersection means we are talking about the numbers which are multiples of both 3 and 4. So these are the numbers which are the multiple of the number 12. So this is the required set that represents the intersection of these two sets. Next we have, if A is equal to, we are talking about the number line over here because it is the interval given to us, and intervals, they are the subsets of real line. It is 0 over here, it is 1, 2, 3, 4, 5, 6, and on negative side we will have minus 1, minus 2 and so on. Now we are talking about this set A. It is the open interval 2, 4. So open interval means 2 is not included, 4 is not included, and we are talking about all the numbers between 2 and 4. Next, B represents the semi open or semi closed interval we are talking about. It is closed at 3, so it is dark over here at 3, and it is open at 5. So it means it contains the numbers from 3 to 5 where 3 is included and 5 is not included. So the intersection of these two intervals, it is this portion over here where 3 is included and 4 is not included. This number 4, it is not included, but this 3 is included. So we are saying that A intersection B, that is equal to closed interval at 3 and open interval at 4. We can also write this interval in the form 3, 4. The next definition we have, it is disjoint sets. So we are saying two sets A and B are said to be disjoint if A intersection B is equal to 5. That is, the intersection of two sets, it is empty set, that is they have no element in common. So we are saying if U is the universal set and these are the two sets, this is the set A and this is the set B, then A union B when A intersection B, it is 5. We are saying their intersection is 5 means that they have no common element. We are saying they have no common element, and this is showing the union. That union means all the elements of A and all the elements of B. And we are saying for the same sets, we are saying these are the two sets A and B. They have no element in common over here. Their intersection, that is equal to 5. There is no shaded region over here. We are saying this, there is no common element. So when we are talking about A union B, it means all elements of A and all elements of B. When we are talking about A intersection B, it means we are talking about the common elements. There is no common element, it means this set it is equal to 5. So these two sets A and B, they are disjoint if their intersection is equal to 5. Next is intersecting sets. So the sets which are not disjoint, they are called intersecting. So we are saying we have two sets A and B, they are called intersecting if A and A intersection B is not equal to 5. That is, they have a common, they have a at least, or A means they have at least one common element. So the examples are given over here. This set A is given, it is 1, 3, 5, 7, 9. This set B is given, it has element 2, 4, 6, 8. And this set C is given, it has element 3, 2, 3, 5, 7 and 11. We have to calculate the value of A intersection B. So we can see A has 1, B doesn't have 1 as the element, 3 is not there, 5 is not there, 7 is not there and 9 is not there. So A and B have no element in common. So we are saying A intersection B, that is equal to 5. That is, these two sets, these are disjoint sets. When we are talking about A and C, so A intersection C, when we are talking about, this 3 is common, then we have this 5 is common, then we have this 7 is common. So A intersection 3 is equal to 3, 5 and 7. So these two sets, these are not disjoint, they are intersecting sets. Next, we have to give the examples of three sets A, B, C such that A intersection B is not equal to 5, B intersection C is not equal to 5, A intersection C is not equal to 5, but A, B, C intersection of these three sets, that is equal to 5. So we have given this example over here. We can see that there is no common element between, there is a common element. We are writing A intersection B, that is equal to 2. When we look at B intersection C, that is equal to 3. And when we look at A intersection C, that is equal to 1. This 1 is common element between these two. We have 2 is common element between these two. And we have 3 is common element between these two sets. When we are calculating A intersection B intersection C, it means we are talking about the common element to all the three, an element which is common to all these three. You can write it is also in the form A intersection B intersection C. It is A intersection. What is B intersection C? It is the set 3. So we are talking about set 1, 2 and intersection with set 3. There is no common element between these two sets. The answer we are writing it is 5. So what we get is that A intersection B is not equal to 5. B intersection C, this is not equal to 5. This is not equal to 5. This is not equal to 5. All these have some elements, but A intersection B intersection C, this is equal to 5. Next is give an example of three sets such that A intersection B is equal to A intersection C, but B is not equal to C. So we have given this example over here. We are saying the set A is elements 2, 3, 1, 2, 3 are there. In the set B, elements 3, 4 are there. So A intersection B, it has element 3 over here. Next, we are talking about A intersection C. So A intersection C means we are talking about the intersection of these two. Again, the answer we are getting it is 3. Both these sets, these are equal to each other, but it is clear that set B and set C, these two sets, these are not equal to each other. This example, this is also important from the point of view that when we are talking about, say, the real numbers, what we have is that A plus B is equal to A plus C. What we say, this A and A, generally we say it like this, but what we are doing, we are subtracting A from both sides and we say that B is equal to C. But this kind of result does not hold for sets. We are not saying that A intersection B is equal to A intersection C. What we are trying to say that you cannot cancel the A. You cannot cancel the A to get B is equal to C. This kind of result does not hold for the sets. The next definition we have, it is difference of sets. So for any two sets A and B, the difference A minus B is defined as, we are saying A minus B, this will be a set. It has elements X. And what kind of elements it has? It has all the elements of A which are not present in B. We are saying that X belongs to A, but X does not belong to B. So in this figure, from this figure, it will be more clear to you that we are talking about, this is a universal set. We have two sets A and B. So what is A minus B? We are talking about all those elements of A which are not part of B. That is, if the list of elements of A are given to us, this is the list of elements of A given to us. From this, we will remove those elements which are part of B. The remaining elements that are over here, that will give us A minus B. That is, from A we have removed the elements of B. That is the difference of two sets. This thing is mentioned over here, that X belongs to A minus B implies X belongs to A and X does not belong to B. So next question we are given is, the set A is X is a factor of 6 and X is a natural number. Set B is X is a factor of 8 and X is a natural number. So the collection, if we form, these are the 1, 2, 3, 6. These are the numbers which are factor of 6 and which are natural numbers. And 1, 2, 4, 8, these are the natural numbers which are factors of 8. When we have to write A union B, it is the set 1, 2, 3, 4, 6, 8. When we have to write A intersection B, it is a set 1, 2. These are the common elements that we have. Next, we have to write A minus B. It means from the set A, we have to remove those elements which are part of B. So 1 is the part of A, B, we have removed this. We have removed this 2, 4 and 8 are not there. So what we are left with is 3, 6. When we have to write B minus A, we are saying we have to remove from B the elements that are present in A. So 1 we have removed, 2 we have removed, 3 and 6 are there. So what we are left with is 4, 8. We are saying from B we have removed those elements which are common with A. This next we have this second Venn diagram. We are saying if A and B, they are disjoint, they have nothing in common, then A minus B we have, that is equal to 5. So we are saying that over here we have A intersection B is equal to 5. It means A and B, they are disjoint, they have nothing in common. Then A minus B will be the set A itself. There is no common element with B, so nothing is removed from this set. So A minus B is the complete set. A minus B is the set A when we are having the condition that A intersection B is equal to 5. Now the next definition we have, it is symmetric difference of two sets. So two sets A and B, they are given to us, and we denote the symmetric difference by A. This is the symbol for symmetric difference, B, and it is defined as A minus B union B minus A. So what this thing means is, symmetric difference means A minus B means we are talking about all those elements of A which are not elements of B. B minus A means all those elements of B which are not elements of A. So how we can explain this situation? Suppose we are having two sets A and B. What is A minus B? A minus B means those elements of A which are not elements of B. B minus A means those elements of B which are not elements of A, and union of these two. This part we are saying this is A minus B. This part we are saying this is B minus A, and union of these two, that is this complete portion we are talking about, that is A delta B, that is symmetric difference of A and B. So this thing will be more clear to you with this example. So we are saying let the set A is equal to A, B, C, D. B is equal to B, D, F, G. We have to find A delta B. So we are calculating A minus B. So from A we have removed the elements from B. So it is A over here. Next B is there, B is removed. Then we are left with this C, and D is also removed because it is present in B. Next we have to calculate B minus A. So B minus A means we are talking about from B we have to remove those elements which are present in A. So B is present in A, D is present in A, F and G, these are not present in A. So the answer we get it is F and G. Now we have to write the value of A delta B, and the formula we have, that is equal to A minus B union B minus A, and the answer we obtain it is A comma C comma F comma G. So what symmetric difference means? We are saying that this intersection part that we have over here, that this part is removed from the union of both these, that there is the common elements that were common to both A and B, they are removed from the union of these two sets. The next definition we have, it is complement of a set. So when we are talking about the complement of a set, we require the universal set with respect to which we have to take the complement. So suppose U is the universal set. This is very important over here. The role of the universal set is very important over here. And A is any set that is a subset of U, because U is universal set, so A will be a subset of U. So complement of the set A denoted by A bar, or it is denoted as A complement, it is U minus A. This is the universal set minus A. We are saying all those elements of universal set which are not elements of A. So this situation is shown in this Venn diagram. We are saying this is the universal set that we have. This is the set A we have. So the remaining part that we have over here, this remaining part over here except for A, this portion we are talking about, that is the complement of A. Now the next question we have is, this set U is given to us. It is 1, 2, 3, 4, 5, 6, 7, 8. These are the elements of this set. And another set A is given to us. We have to calculate the value of complement of A. So we are saying from this set U, we are removing the elements of A. This 2, 4, 6, 8. These are removed. So complement of A will be 1, 3, 5 and 7. So this is the set A dash we are talking about. It is complement of A. Next we have to calculate complement of A. So for this set, we are saying again this is a universal set. So this is the U is the universal set. So now we have to remove the elements of A dash. So when we remove the elements of A dash, what we are left with is, it is 2, 4, 6 and 8. So this is the set A that we obtain again. So this is, we are not proving it over here. I'm just telling you. We will prove in our next slides that we have a formula over there, that A dash that is equal to A. This is the theorem that we will have. We are saying from this thing, it is clear that this result holds, and this result is also true in general. We will give the detailed proof of this in our next slides. Next is, let n be the universal set. Set of natural numbers is given to be the universal set, and the set A is given to be the natural number and x is an odd number. We have to find A dash. So A dash will be x such that x is a natural number, because set of natural number is the universal set, and x is even. We are saying we have all the odd natural numbers. Out of these natural numbers we are talking about, we have removed all the odd numbers. So what we will be left with is all the even numbers. Now the next is, B is a set. It is x. X is a natural number, and x is divisible by 3 and 5. We are saying x is divisible by 3 and 5. So what this thing means, we are talking about, suppose the set C is there. We are saying it is x such that x belongs to n and x is divisible by 3. We are talking about another set D. We are saying it is x. X is a natural number and x is divisible by 5. In the short form we have written it in this form, that x is divisible by 5. So we are saying the set B is basically, the set B we have, it is C and it is and over here. So we get it is C intersection D. It means we are talking about those numbers which are divisible by both 3 and 5. So we are saying what are the numbers divisible by 3? Natural numbers we are talking about, it is 3, 6, 9, 12, 15. Likewise, we will have 30 over here and so on. If we write the numbers which are divisible by 5, we are writing it is 5, 10, 15, 20 and so on. So we are saying what is the intersection of these two sets? So intersection of these two sets, it is 5, it is 15, then 30, then 45 and so on. So these are basically those natural numbers which are divisible by 15. So the complement of this set will be, the complement B dash will be those natural numbers x. We are saying those x is a natural number and x is not divisible by 15. So this is the complement of this set. This question can also be solved using the De Morgan's theorem that we will study later on, which says that B complement that is equal to C complement union D complement. So the complement of these two sets is x is not divisible by 3, x is not divisible by 5. These are the complements of the set C and D, and we put OR in between these two statements and we will get the answer. So both these answers, these are correct. It is up to you that how you want to solve this problem. Now next we have is, if A is a subset of U, U is the universal set over here, we have to prove that complement of U is equal to 5. So what will be the complement of U? We are saying those x belongs to U such that x is not an element of U. So we know that universal set, when we are talking about, and we are talking about the complement, so it is U minus U. It means those elements of U which are not present in U, and that set is basically 5. The second part we have, it is phi dash that is equal to U, that is complement of this empty set. So when we are writing the complement of the empty set, we are talking about those elements of U which are not the element of empty set. We are saying no element of empty set has no element. It means all the elements of U are there in this set. So we get that this answer is equal to U. So we get complement of the empty set, that is equal to U. And the third part we have is complement of A, that is equal to A. So we are saying when we are writing this value complement of A, it means we are talking about those elements from the universal set which are not the elements of A complement. You can look at this A complement as some set B, and you can use this definition over here. It means we are talking about those elements of U which are not elements of A complement, means they are elements of A. We are saying those elements of universal set which are elements of A, those elements they are actually A. So we have started this with complement of A, and we have obtained that it is equal to the set A itself. Next we have to prove that A union A complement is equal to the universal set. So what is A union A complement? We are saying we are talking about all those X in the universal set. What is the definition of union? We are saying this X belongs to A union A dash. So what is the definition of this union? We are saying that X belongs to A or X belongs to A complement. And we know that if we look at the universal set, we are talking about a set A is there. Either A will belong, this is a universal set, either an X will belongs to A complement or an X will belong to A. Both X will belong to one of these two regions. So we are saying what this thing means, that X belongs to A or X belongs to A complement. It means X belongs to A or X does not belong to A. Combining these two results, we will get this is equal to union, the universal set. I am again explaining this portion over here. We are saying what this thing means, that whenever we consider any point over here, either that point will be in the set A or it will be outside this set A. But when we take any point from this set A or from outside of this set A, then we will get the whole universal set U. Next we have is A intersection A complement is equal to phi. What this thing means is, again we have this universal set. We are saying this is the set A. Now if X belongs to U, we are talking about any element X belongs to U, then we are saying that X belongs to A intersection A complement is given to us. And we are talking about when X belongs to A intersection A complement, what this thing means, that either X belongs to A and X belongs to A complement. Now what this condition represents, we are saying if we consider any X that is in A and any X that should also belong to A complement, we are saying we are interested in an element X over here which is present in A and which is also present in A complement. This portion it is A, and this outside region we have from this, it is A complement, and we are saying this is not possible. So this thing is explained over here in this way, that we are saying X belongs to A and X belongs to A complement. So X belongs to A complement means that X does not belong to A. We are talking about the condition that X belongs to A and X does not belong to A. We want such element and no such element is possible. So the answer we are getting, it is equal to phi. So these are four results that we have, that you must remember, that the complement of universal set, that is equal to phi. The complement of the empty set, it is the universal set. The union of the set and its complement, that is equal to the universal set, and intersection of the set with its complement, that is equal to the empty set. These proofs, these are more easy to see or visualize using the Venn diagrams. If we use Venn diagram, these proofs, these are quite simple to realize that what we want to say. Next we have, if A is equal to this set A, B, C, D, E, B is equal to the set A, C, E, G, and C is equal to this set, we have to find the value of A intersection B minus C. So first of all, we are calculating B minus C. B minus C means we have to remove from B the elements of C. So A is there, C is there, E is removed and G is removed. This is the value of B minus C. The value of A we have equal to this. So the answer we obtain, the common elements we have, that is equal to A and C. Next we are talking about A minus B union C. So what is B union C? B union C, we have it is A, B, C, E, F, G. We are writing it is A minus B union C. Now if we look at the elements of A which are not present in this set, you can see that A is present over here, B is present over here, C is present over here, D is not present in this set, and E is present over here. So the answer for this we will obtain, that is equal to D. Next we have to calculate is B intersection C. So from these two sets we have to calculate the intersection. We are talking about the common elements over here. So the common elements we have, A is not common, C is not common, E is the common element, and G is the common element. These two elements, these are the common elements we have, and we are now writing A minus G. Now we have to write those elements of A except E and G. So we are left with this A, B, C, D. So this is the answer for this, that A minus B intersection C. So this is the answer for this part. The next we have, if A is equal to this set, it is 1 by x such that x belongs to n and x is less than 8. So the value of x that we will have, it is 1, 2, 3, 4, 5, 6 and 7. So the set A will be 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6 and 1 by 7. Next, the set B, we are saying x belongs to n and x is less than equal to 4. So the values of x that we will have, it is 1, 2, 3 and 4. It is equal to over here, so we are including this 4. It is less than over here, so it is up to 7. So the set B that we will have, that is equal to 1 by 2, then 1 by 4, then 1 by 6, then 1 by 8. Now we have to calculate A union B. Now the first part we have, it is A union B. So the answer for A union B, that will be equal to 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7 and 1 by 8. Next we have to write A intersection B. The common elements we have, they are 1 by 2, 1 by 4 and 1 by 6. Next we have to write the value of A minus B. It is those elements of A which are not present in B. So 1 by 2 will be removed, 1 by 4 will be removed, 1 by 6 will be removed. So answer we are left with is 1, 1 by 3, 1 by 5 and 1 by 7. And B minus A is all those elements of B after removing the elements of A. So we are left with only 1 by 8. Because 1 by 2, 1 by 4 and 1 by 6, these are present in the set A. So the answer of B minus 8 is set 1 by, containing the element 1 by 8. Next question we have is, if R is the set of real numbers and Q is the set of rational numbers, what is the set R minus Q? It means we have all the real numbers. From real numbers we have removed all the rational numbers. The answer we will be left with is irrational numbers. So all real numbers which are not rational, they are the irrational number. So we are saying R minus Q, this represents the set of irrational numbers. Next is this set A is given to us and another set B is given to us. We have to calculate A union B. This set B is 5. It means it is the empty set. It doesn't contain any element over here. So A union B will be equal to the set A. Next we have to calculate A intersection B. We are saying the common elements between these two. There is no common element between these two because this set does not contain any element. So we are saying the answer we get, that is equal to 5. That is, there is no common element between the sets A and B. Next is, if A and B are two sets such that A is a subset of B. Suppose this is the universal set U. We are talking about two sets A and B, and A is a subset of B. This is the set A, and this larger set we are saying B, and it is given that A is a subset of B, means this set A is contained in the set B. Now we have to find A union B. So what will, this is the set A, this is the set A, and this complete set is the set B. So what is A union B? That will be equal to B. What is A intersection B? What is common of both these? That will be equal to A. This is the common region between both these sets. And what is A minus? Now we are saying we are writing all those elements of A which are not the members of B. But it is clear from here that all the members of A are also the member of B. It means this set will be equal to 5. You can also write this in this form, that A minus B, that is equal to all those X such that X belongs to A and X does not belong to B. But what we have is that A is a subset of B. A is a subset of B means that X belongs to A and implies X belongs to B. So there is no element in this form that X belongs to A and X does not belong to B. So that is why this set A minus B, that is equal to 5. Next is this universal set U is given to us. It is A, B, C, D, E. We are saying the set A is A, B, C. This set B is B, C, D, E. We have to verify that A union B complement. So what is A union B? That is A, B, C, D, E. The complement of this set will be equal to, this is the complete set U, so the complement of this set will be 5. There is no element over here. We are saying A complement intersection B complement. So what is complement of A? Complement of A, ABC is covered. We are saying it is D and E. And we are talking about intersection with complement of B. It is A, B, C, D, E. These all elements, these are over here. And the intersection of these two is equal to 5. Next we have is A intersection B complement. So what is A intersection B? The common elements we have over here, they are B and C. And what is the complement of this set? It is A, D, E. Next we are talking about this set. It is A complement. So the A complement we have, it is D comma E. Union we have B complement. The complement of B that we will have, that is equal to A, and union of these two will be equal to A, D, E, and we can see that these two, these are equal. So we are saying both these conditions, these are verified. Next is, if U is the universal set, we are saying U is the universal set and A is a subset of U, then we have to write the value of A union A complement. This is the set A we are saying. This is the set A complement we are talking about. This outside set we are saying this is A complement. So what is A union A complement? That is equal to the universal set U. What is the intersection of these two sets? What is common between these two sets? It is phi. Next we are saying phi complement intersection A. What is phi complement? It is universal set intersection with A. We are saying universal set is there, and what is common with A? The answer we will obtain, that is equal to A. Next we are saying universal set complement. This complement of universal set. What is outside this universal set? Nothing is outside this universal set. We are taking the intersection with A. We are saying empty set and A. What is common in between these two? That will be the empty set. So the answer we will obtain, that is equal to 5. Next we have is laws of operations on sets. So the first law we have, that is idempotent law, and that says that A union A, for any set A we have A union A, that is equal to A. The proof is quite simple. We are saying A union A means we are talking about all those x such that x belongs to A or x belongs to A. There is no need to write this term two times, so we are just writing x belongs to A. So the answer we obtain, that is equal to A. The second part of this law, it is A intersection A, that is equal to A. So again, when we write A intersection A, but A intersection A means that x belongs to A and x belongs to A. Again, this is equivalent to x belongs to A, and the answer we obtain, that is equal to A. This thing you can also see from this thing that we have this set A. The union of this set with itself, that will be A. The intersection of this set with itself, that will be equal to A. Next we have is the identity law. So it is, we have the set A and U is the universal set. We are saying we are having, this is the universal set and this is the set A that we have. Then A union phi, we are not adding. Phi means it is the empty set. So when there is no element in this, so we are not adding anything to A, so our answer we are obtaining, it is equal to A. So this is written over here that x belongs to A or x belongs to phi. What is x belongs to phi? There is nothing over here. So what we are left with is x belongs to A, and the answer we get, that is equal to A. Second, we have A intersection the universal set. This is the universal set, this is the set A. So the intersection of A with the universal set will again give us the answer as A. So we are saying x belongs to A and x belongs to U. This thing is always true. This thing is always true. So no need to write this, and it is and in between these two. That is to satisfy x should satisfy both the conditions, that x belongs to A and x belongs to U. So what we are left with is x belongs to A. So the answer we obtain, that is equal to A. So what we are saying over here is that phi and U are the identity elements for union and intersection of the sets respectively. Identity element means, we are saying for union means, if we consider any set A, we are taking union with phi, the answer we are obtaining, it is A. Identity element means, suppose for addition we are saying any element A is there. If I add 0 to it, the answer I will obtain, it is A. If I am talking about multiplication, I am saying any element number A is there, I am multiplying it with 1, the answer I am obtaining, it is 1. So additive identity is 0, multiplicative identity is 1. Similarly, in case of sets, we are saying the identity for union, it is phi, and identity for intersection, it is the universal set. That if we take the intersection of any set with the universal set, the answer we obtain, that is equal to the set itself. Next we have is the commutative laws. Now we are saying commutative means, when we are talking about the numbers for addition we are supposed talking about, then we are saying A plus B is equal to B plus A. These kind of laws we are saying this is commutative law for addition. So in case of sets, we are saying we are having two sets A and B, and we have A union B. that is equal to B union A, and A intersection B that is equal to B intersection A. Proof of both these are almost similar. So we look at the proofs first. So when we are talking about the commutative law for union, so suppose we are saying X is any element we have considered from A union B. So what this thing means that X belongs to A or X belongs to B. We can interchange these conditions like this, that X belongs to B or X belongs to A. So this thing gives us X belongs to B union A. So what this thing means, we have started with X belongs to A union B. We are saying X belongs to B union A. So combining these two results, we get that A union B is a subset of B union A. We are saying every element of A union B is an element of B union A. Similarly, if we are writing X belongs to B union A, or in place of X now we can write it as any element Y is there which belongs to this, then we have X belongs to B or X belongs to A. This gives us X belongs to A or X belongs to B. This gives us X belongs to A union B. It means you can write X or you can write Y. It is up to you that how you want to write. So what we get from this is that B union A, it is a subset of A union B. So now we have obtained two conditions over here, that A union B is a subset of B union A. Second we have is B union A is a subset of A union B. Combining these two results, we obtain that A union B that is equal to B union A. Why? Because we know that if A is a subset of B and B is a subset of A, then this combined result gives us A is equal to B. Now the second part we have, it is for intersection. So if we replace this union with intersection over here, this OR will become AND, this OR will become AND, this will become intersection, these all symbols will become intersection. Similarly, this second proof will change. The final answers we will obtain, it is A, B intersection A is a subset of A intersection B. Combining these two results, we will obtain, we are saying we are combining these two results, that A intersection B is a subset of B intersection A. B intersection A is a subset of A intersection B. Combining these two results, we will obtain that A intersection B is equal to B intersection A. Now the next we have, it is the associative law. So for numbers, the associative law, suppose I am talking about addition, we are saying it is A plus B plus C that is equal to A plus B plus C. So what this thing means, if we have to add three numbers, we are saying we are adding A and B, and then to the answer we are adding C, or we can add B plus C, and to this answer we can add A. The final result will be same. Similarly, the associative law for the sets, when we are talking about for union, we are saying it is A union B union C that is equal to A union B union C. That is, first we take the union of A and B, and then we take the union of C, or first we take the union of B and C and then we take the union of A. The answers will be same. Similar is the case with the intersection. So we start with the proof. How we are going? Important thing to note over here, it is we have to prove this equality. So we are going to prove two results, that this set, this first set is a subset of second. Next we are going to prove that the second set is a subset of the first. Then by combining these two results, we will get the final answer. This is our basic idea of the proof. So what we are going to do, we are saying suppose X belongs to A union B union C. What we have to do, we have to prove that X belongs to A union B union C. if we could prove this thing, then it means that this set A union B union C, this set, it is a subset of this second set. So we start this with, when we write this condition over here, we are saying this thing means that X belongs to A union B or X belongs to C. This thing means X belongs to A or X belongs to B or X belongs to C. This gives us X belongs to A or X belongs to B or X belongs to C. Now if we put the bracket on these two, you will get, this implies X belongs to A or X belongs to B union C. What this or means over here? It is union for this. So we obtain that X belongs to A union B union C. So this part is proved. Similarly, we can prove the second part. When we are talking about the converse part, we are just writing these steps in this direction. We are saying X belongs to A union B union C. Next we write this step, next we write this step, next we write this step, and we obtain that X belongs to A union B union C. So we get these two results, that this is a subset, this first set is a subset of second set is a subset of first, and combining these two results we obtain that both these sets, these are equal. Similarly, for the intersection part, if we are using in place of this or, what we will get, it is X belongs to A intersection B intersection C. It means X belongs to A intersection B and X belongs to C. X belongs to A and X belongs to B and X belongs to C. So just in place of this or, we are getting and over here. So this thing gives us X belongs to A and X belongs to B and X belongs to C. Now we put bracket on these two terms, we get X belongs to A and X belongs to B intersection C. Now combining these two results, you will get X belongs to A intersection B intersection C. So both these are, from this result we are getting X belongs to this term, A intersection B intersection C implies X belongs to this term. All these terms we are having, this implies this. So what we get is, we get this first part of the proof, that A intersection B intersection C, it is a subset of A intersection B intersection C. Now if we write all these steps in the upward direction, we start from this, we write all these steps in backward direction, we will get the result that A intersection B intersection C, that is a subset of A intersection B and its intersection with C. So combining these two results, one set is a subset of second set is a subset of first, combining these two results we will obtain that both these sets, these are equal to each other. Next we have is distributive laws. So we are saying for any three sets A, B, C, when we are talking about distributive law for the, say, real numbers, we are talking about for addition over multiplication or distributive law of multiplication over addition, then what we have is that A into B plus C, that is equal to A into B plus A into C. So over here we have two laws over here, that is union is distributive over intersection, second is intersection is distributive over union. So if we are able to prove one of these, the second is just the similar proof that we will have. So we are saying how we are going to prove the equality over here. Again, to prove this equality we have to prove two things, that first we have to prove that first is the subset of the second. In the second part we are proving that second is the subset of the first. combining these two results, we will get that both these sets, these are equal to each other. So we start with the left hand side of the first, and we are saying X belongs to A union B intersection C. So we are writing that X belongs to A, it is union over here, so it is or X belongs to B intersection C. Now what this thing means, it is X belongs to A, or now what we have, X belongs to B and X belongs to C. We are having this condition over here. So what we can say, that X belongs to A or X belongs to B and X belongs to A or X belongs to C. Now what this thing means? This thing means X belongs to A union B and X belongs to A union C. Now what this AND means over here, that it is A union B intersection A union C, that is this X belongs to this. So what we get is that for X belongs to A union B intersection C, X belongs to A union B union A union C. If we write these steps in this direction, these all are implying each other. So basically we are saying these are imply and implied by each other. Both directions they are true. So we will get that this is a subset of first. So we are obtaining two results from this. One is this result, that first set is a subset of second. Second, we are obtaining second set is a subset of the first. Now combining both these results, we will obtain the equality sign over here. This is subset of this superset you can say, and combining these two results, we will obtain that both these results these are equal to each other. Similarly, if we replace this OR with AND this AND with OR, we will obtain these second results. We are talking about these results over here. We will obtain these second results, that this first is subset of second and second is subset of first. We are talking about these two results we will obtain, and on combining these two, we will get the final result in this form. And we are saying both these results, they are the distributive laws for sets for distribution of union over intersection or intersection over union. Next we have is the De Morgan's law. So it is for any two sets A and B, we have to prove that A union B complement, that is equal to A complement intersection B complement. So to prove this first part, we are saying suppose X belongs to A union B complement. So if X belongs to this, it means X does not belong to A union B. If X belongs to the complement of A union B, it means X does not belong to A union B. Now what this thing means, this thing is just that X does not belong to A and X does not belong to B. We are saying it is union over here, but we are writing it as AND over here because it is does not belong to the union. If we are talking about the universal set, these are the sets A and B, and we are saying that X does not belong to A union B. It means X is outside this portion. It means neither X belongs to A nor X belongs to B. So we have X does not belong to A and X does not belong to B. So this gives us X belongs to A complement and X belongs to B complement, and this gives us X belongs to A intersection A complement intersection B complement. In place of AND, we are writing it as intersection over here. So same steps we are talking about. we are writing that X belongs to A intersection B complement. It means X belongs to A and X belongs to A complement and X belongs to B complement. From this we can write X belongs to A, X does not belong to A and X does not belong to B. From this we can write X does not belong to A union B, and this thing gives us X does not belong to A union B complement. So these are just the reverse steps we are talking about. So from the two results we obtain that A union B complement is a subset of A complement intersection B complement, and A intersection B complement is a subset of A union B complement. Combining both these results, we obtain the given result that A union B complement, that is equal to A complement union B complement. Similarly, in the second case, we have, in this case, we are proving the first part. We are saying it is X belongs to A intersection B complement. It means X does not belong to A intersection B. We are saying this is the universal set. Suppose A and B's are the set. So X does not belong to A intersection B. This is the portion A intersection B. So what we can write from this is that either X does not belong to A or X does not belong to B. So this thing gives us that X belongs to A complement or X belongs to B complement. So we get X belongs to A complement union B complement. Again, in this case, we are saying both the sides, they are these all conditions, these are if and only if conditions. So what we get is that if X belongs to A intersection B complement, then X belongs to A complement union B complement. This is our first part. And second, we obtain that A complement union B complement, that is equal to, that is a subset of A intersection B complement. Again, on combining both these results, we will obtain the equality over here, and the answer we get is that both these sets, these are equal to each other. And these two laws, these are called the De Morgan's